This time I will solve an example on development length. Say this is my beam. What is this beam? It has 3 reinforcement, 3 number 9. The tie bar number 3 at the rate of 7 is center to center. And the cover here from center of the bar to the surface is 3 inch. Center of the bar to the surface is 3 inch. And the spacing of the bars are 3 inch, 3 inch. It is epoxy coated bar, lightweight concrete. AS required is 2.76 inches square. A prime C 4000 psi, Fy 60,000 psi. So this is my beam. After designing, we got this beam. Now we will have to calculate the development length when my TR is 0 and development length when TR is calculated. So we need to calculate, determine it. Now, so if I start, so at the beginning we are doing number A. What is the equation of development length? So 3, 40, Fy, lambda F prime C, psi T, psi E, psi S divided by CB, KTR divided by diameter of the bar times the diameter of the bar. So this is the equation. This equation is very simple. You can just memorize or you can take it from your book. So we will find the values one after another. Fy clear cut 60,000 psi. A prime C 4. Okay, so we got this one. Fy done. A prime C done. There is no question here. Lambda. Is it lightweight concrete? Yes, lightweight concrete. Then what is this factor? This factor is 0.75. Now, depending on specification, this factor might change. So now we are using 0.75 because this is the current specification. Okay, but then KTR, we are solving first one, so we will assume this one is 0. Diameter of the bar, number 9 bar, right? So number 9 bar means diameter, if I can remember, I cannot remember actually. I can use my calculator. Is 9 divided by 8, 1.125. So 1.125. Okay, so same thing here also. This is done. CB, what is CB? If you can remember, it is smaller of distance from center to the surface. So here to here, that means here to here is 3 inch, or center to here is 3 inch. So smaller of this or half of this center to center spacing. Okay, so one is 3 inch. All right here. So CB, one is 3 inch, other is half of 3 inch. So what is this 3? This 3 is actually this or this. This is this 3. And this 3 inch means this one. So we are getting smaller. So it will be 1.5 inch. Because this will be smaller. So CB will be 1.5. So CB is done. Psi T, reinforcement location factor. If I have more than 12 inches of concrete below the bar, so below the bar I have only very small 1.5 inch or something, because from center to here is 3 inch. So the reinforcement concrete here will be about 1.5, 1 something. So at least not 12. So psi T is 1. So this value is 1. So now this one size factor. If it is number 7 or above, it is 1. So my bar is number 9. So psi S is also 1. Epoxy factor. So it is a epoxy factor. Epoxy coated bar. We know that for epoxy coated bar, it can be psi E can be 1.5 or 1.2. If it is not epoxy coated, then 1. Now which one? This one applies if the K bar is less than 3 times bar diameter, or the or the clear space is less than 6 times bar diameter. If you can remember, go back to your book, and then when it is 1.5, simply if cover, okay, or right here. So epoxy 1.5, if cover less than 3 times bar diameter, or clear space less than 6 times bar diameter. That means bar diameter is how much? 1.125. Cover is less than 3 times. Yes, because it is this 3 is from center. Only the cover should be less than this. But it is, yes. If the clear is less than 6, obviously, because center to center is 3. If I deduct some bar here, half some bar here, clear will be roughly 1 is 1.5 like this. So it is clear that this one applies. So yes, this is my value. So psi E is 1.5. Now the product of these two cannot exceed 1.7. Yes, they are not exceeding 1.7, so they are good. Okay, so if I do the calculation, I don't know how much I will get. So I'm doing very quickly. 3 times 40 times 60,000 divided by 0.75 divided by A prime C is 4,000 times 1.5 times 1.125 divided by, what was the value of CB? CB was 1.5. After calculating, I got 135 inch. Now I did very quickly and I did not say double time. So maybe my calculation is mistake, but at least you know the values. Calculation should not be a problem. Okay, so with KTR 0, I got 135 inch. Now, how much reinforcement I am providing? I am providing 3, number 9. How much do I need? 2.76. So what is the factor? Factor is AS required divided by AS provided. So I need 2.76. I am providing 3, number 9. The area of number 9 bar is 1. So 3 times 1. What is my factor? 2.76 divided by 3.92. 0.92. Okay, then my final LBD will be 135 times 0.92. Roughly 124 inch. So 124 is if my KTR is 0. Okay. So now we will solve this one with KTR calculated. Okay. So do not forget it. At least I am writing it here so that I can remember. 124 is. Okay. Now I will do number 2. Again, I will need this. I can remember this. 192. So this time my KTR is not 0. We have to calculate KTR. Now how to calculate KTR? If you can remember, you can do it this way. ATR, 40 ATR, SN. This is one equation, or you can use this equation. ATR, FY, TR, 1500, SN. Both equations will give you same answer, same thing. Okay, so you can use any one. Say I am using this one. So 40. What is the ATR? Area of the transverse reinforcement. It's number 3 bar. 1, 2. So 2 bar. So 2 bar, each one is 0.1 inch square. Why it is 2? 1, 2. Yes. What is the spacing of the bar? Spacing is 7 inch. 7 inch. This is spacing. What is N? N is number of bar. 1, 2, three bar. So 3 bar. If I calculate very quickly, I got 0.42. Okay, 0.42. Now I will have to say this portion we know that cannot exceed 2.5. So what is this value? CB was 1.5, KTR was 0.2, diameter of the bar is 1.125. What is this value? 1.5 plus 0.42 divided by 1.125. So this value is coming 1.7. Yes, it is less than 2.5. Okay, it is less than 2.5. Okay, okay. So we are done. 0.42. Okay, so we got everything, or we can insert 1.7 directly here to make our calculations easy. 1.7 here, simple. Okay, to the calculation, 3 divided by 40 times 60,000 divided by 0.7 divided by 4,000 times 1.5 times 1.125 divided by 1.7. This time I got 94 inch. And what was my factor? A is required divided by A is provided. You can remember it was 0.92. So my LD is coming 0.92 times 94. 87 is. Last time we got 120. Last time we got 124. This time we are getting 87 inch. Let me check with your book anything I made mistake. Okay, no, I think it is okay. Whatever your book gave us, there's no more information. So everything looks good to me, unless there is some rounding error or there is any other this kind of error. So you can see if I use KTR is 0, it is way or conservative and over design. So it is better to calculate KTR. And we calculated KTR and then we are getting 87 inch. I'm thinking, did I consider this when I did this calculation? So I will check one more time. Because every time I do calculation, I forget this one. So 3 divided by 14 times 60,000 divided by 0.7 divided by 4,000, 1.5, 1.125, 1.7. Yes, it is right. Okay. So hopefully what you understood is calculation is not the main thing. Main thing is like identifying the different parameters. So hopefully you understood. In my next video, I will solve another example. Thank you.